Hello, everyone, and welcome to our presentation on fake news detection. We're Group 32, and today we're going to be discussing our project on using deep learning models to identify fake news articles. So, the spread of misinformation, especially in this digital era, has significant societal, political, and economic consequences, and we commonly see fake news impacting elections, public health, and public trust. So, because of this, there's a real need for reliable and automated fake news detection tools. So, in our project, we've developed a deep learning model to classify news articles as real or fake, and we've focused on identifying patterns in the language of fake news. So for our data source, we used a data set from Kaggle called the Fake and Real News dataset. It contains CSV files with news articles categorized as either real or fake, along with the article's title, main text, and topic classifications. This dataset allowed us to work with raw, unstructured text, which we then pre-process for our model. For the inputs and outputs, the inputs to our model are raw news articles in text format. We pre-process the text using several techniques, which I'll talk about later. And these pre-processing steps really helped us transform the text into numerical features. And our model outputs a classification label where 0 represents real news and 1 represents fake news. Coming to the evaluation metrics, we use several metrics where accuracy is a very straightforward one. It just shows you the proportion of correct predictions. However, we also look at the confusion matrix to understand the types of errors that our model makes, and it helps us break down the predictions into true and false positives as well as true and false negatives. The last one is a combination of three different metrics. So we use the classification report to look at precision, recall, and F1 score, where precision is the accuracy of our positive predictions. Recall shows us how many actual positives were correctly identified, and the F1 score gives us a balanced measure of precision and recall. We did some data analysis before we started this project, and we noticed that fake news tends to have a lot more words than real news does. Coming to data preprocessing, we use these main methods. So we use stopword removal, where we remove common stopwords using NLTK stopwords corpus, along with the GenSim custom stopwords. We also did stemming and lemmatization. So stemming is essentially reducing words to their root form, whereas lemmatization is to convert words to their base form. We also did text cleaning using regular expressions to remove punctuation, special characters, and numbers. For tokenization, it depends on which model we're using. So for the baseline models, we use the TF-IDF vectorizer, whereas for the LSTM and bi-LSTM models, we use the NLTK word tokenize. For BERT, we use BERT's own BERT tokenizer. So for our baseline model one, we used a fine-tuned naive Bayes model, and we tuned the alpha parameter, which controls the overall smoothing of the model, and we performed a grid search over the different values of alpha. We were able to get a top accuracy of 92.65% with about 700 misclassified instances. Our second baseline model is a fine-tuned logistic regression method, a model with very similar fine-tuning, and we were able to get a top accuracy of 99.34% with only about 60 misclassified instances. Then we decided to use LSTMs because LSTMs are great for handling sequential data, and we use them with NLTK's word tokenizer to model the sequential dependencies in the text. We performed hyperparameter tuning to optimize the number of LSTM units as well as the learning rate for the best accuracy. So we were able to get a top accuracy of about 99.47% with only about 50 misclassified instances. So we thought since we did LSTMs, we should also check out bidirectional LSTMs. The key difference here is that bidirectional LSTMs process sequences in both directions, from left to right and right to left, which allows it to capture more context from the text. We use very similar hyperparameter tuning, and we were able to get a top accuracy of 99.25% with about 70 misclassified instances. So our final model was BERT. BERT is it stands for bidirectional encoder representation of transformers, and it's a deep learning model introduced by Google for NLP tasks. And we noticed that using a pre-trained transformer model designed for NLP tasks would provide the best results. And BERT also reads text bidirectionally, which means it considers the entire context at once, which makes it highly effective for NLP tasks. Talking about the architecture a little bit, BERT uses a transformer-based architecture with multiple encoder layers. For the base model, there's 12 layers, each with multi-head self-attention and feed-forward layers. The attention mechanism allows the model to focus on different parts of the text and capture content from both directions, and the final output is then processed through a fully connected layer, which provides contextualized word embeddings for downstream tasks. So for the accuracy, we got 99.7%, and we only had about 28 misclassified instances. This is a quick comparison of the accuracies for the different models. So you can see that even though multiple models have very high accuracies, not all of them were as effective in actually classifying the different instances. So for our future scope, there are several ways we can improve it. We can experiment with more advanced architectures like BART or Roberta. Additionally, we could also combine multiple models using ensemble methods for higher accuracy. A fun area to explore would be multilingual fake news detection, which would require fine-tuning models on non-English datasets. And real-time detection of fake news is another exciting avenue. So our team does have prior work in NLP tasks, but this project helped us extend our knowledge by incorporating transformer-based models like BERT, as well as expanding our work to tackle more complex tasks like fake news detection and handling larger data sets with sophisticated pre-processing. These are some of our references. Thank you.